All right. So, shut up! All right. So, number one. And surprised how many, we spent like the first whole day of class talking about this. MtGox missed a lot. So first of all, it was a website. It was actually a repurposed website. It used to be a site for Magic the Gathering Online for trading cards. Was later repurposed and it became the largest Bitcoin exchange. Largest Bitcoin exchange. I think a couple people were talking about it was what processed Bitcoin transactions like before the blockchain or something. Now, this was very similar to Coinbase, a place you could go to and get Bitcoin for other fiat currencies. Okay, so that was enough. You could have also gone on to say that it was the, MtGox. It was the biggest exchange and then failed due to a big security breach, blah, blah, blah. But, give me some indication you knew what MtGox was. Questions on that one? All right. What is the blockchain and what are its strengths and weaknesses? So the blockchain in general is a ledger of all Bitcoin transactions that have ever occurred. Okay, so you could have listed different strengths. What's one strength of the blockchain? Well, it's secure because it's every single transaction that's ever occurred is on there. So we can go and validate those transactions. You could make the argument that it can't be manipulated. You could also use that on the weakness side and say, unless you have 51%. If you have 51% of the mining power, you potentially could manipulate the blockchain. Downside of the blockchain, it's very, 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 very large. So with the good comes the bad. So we have this giant ledger that exists a zillion times out on the internet, and it's huge in terms of file size, and it's just arbitrarily growing larger. So every single day, like, I want to see what the, volume of transactions that occurred yesterday. Let's see. There was 141,000 transactions using the blockchain yesterday. A lot of transactions. Probably less transactions than there were made using US dollars yesterday, but probably more transactions than were made using Apple Pay today. I'm specifically going to McDonald's tonight to use Apple Pay. Man, plus I might get to meet LeBron. Maybe he'll be at the Grafton McDonald's. He doesn't even look like LeBron James with the metal hat on. His head looks extra small, doesn't it? You even know what I'm talking about? Monopoly commercials?
I haven't seen them.
Oh.
I honestly don't watch, like, TV. Like, on TV.
Somebody else once said they didn't watch TV. They've been branded Amish ever since. All right. So, that's number 2. Questions about that? After class, if you think I ripped you off on points, come up and I'll explain why I took off whatever, or give you points back if you think I wasn't fair.
So, we think that you weren't there?
Well, you can challenge me. I'm pretty direct. So if I truly wasn't fair, I'll give you points back. If I think I was too fair, I might take points away. Like, wait a minute, I missed this one. Let's see. Number 3, is mining necessary for a cryptocurrency to work? Why or why not? Well, you could answer this actually either way. I think we had one person, if I remember correctly, who said no, it's not necessary. Specifically because the currency could exist without mining. That is, all coins that have been created up to today would be in existence. You couldn't make transactions, and you wouldn't get more currencies, but it could exist, and you could argue that maybe that means that the cryptocurrency works. But generally speaking, what I was looking for here is, no, mining is required. Or is mining necessary? Yes, mining is necessary for a cryptocurrency to work. Mining is the means by which new coins are born and also by which transactions are validated. So we can't have transactions without mining. So we can't actually send money to anybody. And new Bitcoins are not, or new cryptocurrencies are not born and put into the system without mining. Two big deals. All right, questions on that one? How are Bitcoins created? Well, the act of mining. So approximately every 10 minutes, a block is found by one of likely the mining pools, which is a big collection of Bitcoin miners who have put all their hashing power together. And all of these miners are making guess after guess after guess of which hash will unlock that block, right? And whoever wins gets awarded, through the mathematical algorithm, the brand new Bitcoins. Right now, the new Bitcoins that are born are 25 every 10 minutes. And then those 25 are disseminated to the winner, probably the pool, and the pool decides how to share it with its constituents. So that's how new Bitcoins are born, through the act of mining. Questions on that one? Let's see. Why does the difficulty of the Bitcoin network adjust, and how often does it adjust? Well, the difficulty of the network adjust, as we talked about in the previous thing here, is we have this 10-minute thing. So every 10 minutes, new Bitcoins are supposed to be born. If Bitcoins are being born too often, we need to adjust that difficulty so that all the Bitcoins, or at the very least, that too many Bitcoins are not born too quickly. So if the mining power went up drastically overnight, we would start mining Bitcoins in far less than 10 minutes per coin, or per 25 coins. So that's why every 2 weeks, amount of time is about 14 days. I think it's every 2,048 blocks, which comes out to about 14 days. 2,048 might not be right. Something like that. 2016? 2016 days, or 2016 blocks, which comes out to about 14 days, assuming 10 minutes per block. We adjust it. Typically it goes up in difficulty because through ASICs, which is question number 10, our network difficulty has to keep going up to keep up with the faster and faster and faster mining performance. Okay? So, difficulty adjusts to try to maintain that 10-minute birth rate for new Bitcoins. That's why it adjusts, either up or down. And it adjusts every, you could have said 2016 blocks. I accepted anything in the 2000 range, or 14 days, or about 2 weeks. It's acceptable as well. Things that were not acceptable that were said was 10 minutes. Although that is an interesting question. Why doesn't the network difficulty adjust more often? Kind of taking a slight segue out of, from that question. So in fact, Bitcoins, it does update every 2 weeks. But why doesn't it update more? Go ahead.
Because it's a guess. It could be in 1 second. It could be in an hour. If it adjusted based on the 1 second, then it's going to adjust a lot so that you're going to be guessing them a lot faster.
So it's based on the average block time over a period of time. Right? So could you make an argument that maybe you can make it more or less than 2 weeks? You might be able to make that argument, right? But from what you're saying is that if we made an adjustment on a per block basis, we might hit the lottery and one block might get done in 5 seconds. Or use the example of 1 second. Very first guess, done. Well, all of a sudden the Bitcoin difficulty is going to drop to nothing. Well, actually, it'll go through the roof, right? In that case, if we solve it in a second, then the difficulty will just fly up and we'll never mine another block. It's just so impossible. It's 6.5 years, we're still working on the block. So we really need a average over some period of time. You can make an argument over how much time, but they picked 2 weeks. I'm sure there's a good statistical reason that 2 weeks makes a lot of sense for that number of blocks. Because even now, like if I look at the, I have an app that shows me what the last block. Oh yeah, see here, this is interesting. The last block time was 59 minutes and 45 seconds. So if we were going off of that, oh, you didn't jump that time. So if we were going off of that, the Bitcoin network would drop in difficulty a lot. But I think I checked this earlier today, and the last block was like 3 minutes. Which actually becomes interesting. I wonder what percent, it would be interesting to look at. I don't know the answer to this. But I wonder what percent of blocks actually happen in 10 minutes. I know there are many that happen in there. But in terms of the actual percentage of blocks, I wonder how many of them actually occur in that range. Kind of interesting. Okay, questions number 5. 6. What is the difference between a GET and a POST HTTP request? Well, a GET passes the variables through the URL. A POST does not. POST passes them through the actual form. The web form puts it as part of the package that gets sent with the POST request. So the big deal is one sends everything through the URL, the other one does not. It's not that one is encrypted and the other one is not. That has nothing to do with it. It's not that one's used for authentication, the other one's not. Typically, POSTs are used for authentication, where GETs are not. But you know, a POST is really no more secure than a GET for authentication, unless you're doing it over a SSL connection or something. You know, a POST is not. The stuff is still there in plain text. It's just not overtly in the URL. Questions on that one? All right. Describe how our Bitcoin-based payment system using Coinbase worked. What was the process of making a payment? Okay, well, so we figured out how much somebody owes in Bitcoin. Then we figured out how much will that Bitcoin cost. So now we need to go buy that number of Bitcoins from Coinbase. So we convert US dollars into Bitcoin, use the blockchain to send Bitcoin to the recipient. And then in the end, the recipient could choose to keep it in Bitcoin, or we could also use Coinbase to convert it back to US dollars. With the idea being that that transaction fee using only Coinbase, the stock version of Coinbase, is 1% to get in and 1% to get out. And the blockchain transfer is free. So that's a 2% fee total, which we decided beats most credit card fees. All right, so that's kind of the gist of our what we did. You could have gone into more detail and talked about sending private keys and nonces and things like that. That's fine, but I at least wanted you to capture the mentality of the transaction. US dollars to Bitcoin, use the blockchain, convert Bitcoin back to US dollars. Something like that. Questions on that one? All right. What is an API and why might they use JSON? So an API is an abstract programming interface. It is typically a set of instructions or a set of functions for communicating with a data source. In our example, we were communicating with Coinbase. We were telling Coinbase to buy stuff. We were requesting Coinbase to tell us balances, that kind of stuff. So it gave us a set of functions for interfacing with data that's stored at a third party. All right, so that's kind of what an API is. Now, why JSON? Well, JSON is a data representation language, much like XML. The way it looks is common to programmers. So the same people who would be using an API would be very accustomed to looking at JSON-like documents, just from their programming. XML is a lot harder for a human to kind of sift through. You could also technically make the argument that XML is slower. I'm not sure that's necessarily a great argument because we can parse both of them really, really, really fast. But certainly a good argument is XML has a lot of wasted text, a lot of wasted space. So if anything, we could say JSON is more efficient because we're actually sending less data. It's representing, our objects, but we're actually physically sending less text to represent the same amount of data. But certainly, maybe the best answer is JSON is a standard. So if we always use JSON for our APIs, now we're working with a standard language where there's standard libraries for parsing it, even though we've chosen to write our own language for parsing it, or our own library for parsing it. JSON is a standard. All right, questions on that one? What is the role of a nonce in the Coinbase API? This one was actually missed a lot. We talked about nonces a lot because, I don't know, it's kind of a fun word to say, I guess. But a nonce is just an integer. It's a random integer that in Coinbase's case, and in most cases, must be larger than the previous nonce you came up with. Usually that's in with a threshold of time. But for the purposes of this question, a nonce is an integer, and we use that integer as part of the value that we're hashing for our signature. And what it allows us to do is, as we make multiple calls to the API, each call will actually be a different hash value. Because even if everything else remains the same, we're changing that nonce, which produces a brand new hash. Increases the security. So that nonce increases the security of transactions between an end user and Coinbase, or our program and Coinbase. Make sense? Just one more thing that switches up that hash value. Is the nonce necessary? Another question I could have asked here is, what's a hash? So a hash is a one-way cipher, right? So the idea is you take an arbitrary amount of input and compress it down to a finite number, a finite size output. And the concept is we should not be able to recreate our input from the output. Does having that nonce make that any more secure? So why do it? If I can't decrypt a hash, if I can't get back to my initial input in the first place, and we're saying the nonce is not really a secure value, right? So if I can't get back to the original value anyways, in fact, in Coinbase, we're also sending the nonce ahead in plain text, too. We're saying, hey, here's our hash, and by the way, here's the nonce we used to make it. Good luck. Go ahead.
So that it randomizes the hash more, so you're not duplicating, you don't have duplicating hashes.
Okay, why would duplicating hashes be a problem? just cause.
You're wasting your time then. I mean, if you're limiting the number of hashes, you're setting a limit on your hash rate, technically, if you didn't have that, or you could potentially.
What would happen if we didn't use, what could happen if we didn't use a nonce? Give me a kind of a worst case scenario. So we use our program we wrote, and we request that $100 in Bitcoins be purchased and sent to Abe. If we didn't use a nonce, what could happen? It's called a replay attack. I could literally snoop the network, see that you sent some Bitcoins to Abe, and I can replay that exact same packet. Abe gets Bitcoins twice. Abe's not going to complain about that.
Yeah,
but now, depending on how the API you're using works, you might be able to rewrite parts of that packet to send those Bitcoins someplace else. So what if I'm able to rewrite the to address? Maybe that's not contained in the hash. So now instead of, sending Abe Bitcoins, I'm going to send myself Bitcoins. But because I use the exact same hash to authenticate this time, because the nonce isn't used to uniquely identify successive hashes, I could just replay it and just keep sending Bitcoins. Have we hurt ourselves by sending the nonce along in plain text? Why?
No, because if you were to try to replay with a nonce, it would fail because the next nonce would have to be a larger number, and so just having it in plain text doesn't do anything, because it's connected to that hash value.
Okay. We could not have created the hash with just the nonce and the plain text. We needed the private key, correct? So somebody who's intercepting that packet, even if they have the nonce, they couldn't create a new hash without also having our private key. So really the thing that the nonce protects us against is that replay attack, where we're sending the same packet multiple times and it's getting executed multiple times. Now, it also isn't even a replay attack that it also secures us from. It also secures us from accidentally calling the same thing more than once. What if we just kept sending the same packet over and over and over again? Our code had an infinite loop. And we saw in class that we could accidentally, put the wrong number of Bitcoins we're going to buy. Instead of buying 0.1, we buy 100. And all of a sudden, the charge of my Coinbase account is going to be slightly different, right? Go ahead.
I was just going to say, depending on where the infinite loop was, if you got the nonce inside that loop, it would be different every time because you're looking at the current time.
Really depends, though, because the amount of time it takes to send a packet out, the threshold, I've seen this happen. So it kind of depends on the network library you're using. The distance, we don't know the distance that they're requiring the next nonce to be from the current nonce. What I've gathered is it has to be a pretty big jump, relatively speaking. In a program I wrote, that Kribix program for the iPhone, I've had to put some sleep commands in there to make it go to sleep for like 1 or 2 seconds before it grabs the next nonce. Otherwise, it thinks they're the same value. Yells at me saying, nonce must be larger than the previous one or something like that. In a loop, I think it would be too close. So it would actually still fail, having it 2 times in a row. Because the loop's going to go through really, really quick. So I think those nonces would be the same, within the realm of these are the same nonce. It hasn't incremented. Okay. So let's see, what was that? Number 9. Questions on number 9. Number 10, how have ASICs impacted the Bitcoin mining industry? Has it been a positive or a negative impact? Explain. So first of all, what is an ASIC? Application-specific integrated circuit. Okay, these are the specific machines built for mining Bitcoin or mining cryptocurrencies. How have they impacted the network or the mining industry? Well, since they keep coming out every couple of days and we keep one-upping each other, the mining power on the Bitcoin mining network keeps going up, 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 up. So people who spent money 6 months ago, their equipment, while still working, has less of a positive impact on the network than it did 6 months ago. So even though they're still playing their part in the mining world, they're getting less and less back for their contributions because their contributions represent a smaller percent of the contributions that time around. Okay, and this is related to the difficulty also going up. So as the difficulty goes up, 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 our contributions become even less. So now the guy next door is mining 5 times faster than we are, and our mining is half as effective as it used to be. Anyways, because of the difficulty in the network. So that's kind of the situation of ASICs in the mining thing. So now we can say, has it been a positive or a negative impact? Well, you can kind of argue either way. Some people said it's a positive impact because it's kind of put Bitcoin on the map. You know, it's made a lot of news stories and things like that. You have, you know, now you have enterprise type places building the equipment. You have enterprise type places actually doing the mining. You have new industries growing with cloud mining and that kind of stuff. So perhaps the advent of these ASICs and the industry that it created has been has had a positive impact on Bitcoin and other cryptocurrencies because it's put it in kind of the forefront. How has it been negative? Well, maybe kind of pushes out the little guy. You know, unless you're going to put a bunch of money into equipment, having the, you know, making a lot of money off mining maybe becomes problematic. What's been done more recently to fight this? I know a couple of you mine in here. How do the little guys leverage their chance to make more Bitcoin? Okay, we have pool mining, but that doesn't necessarily help because we're still a little fish in a big pond, right? I mean, pool mining is basically the only way to mine Bitcoins now. But really, I'm talking over the last like 4 months, let's say. The little guys, meaning, you know, normal folks that go out and spend $1,000 or something like that on mining equipment. And that mining equipment is now worth a lot less than it was before, but we still have mining power. What have those guys been able to do, for those of you who kind of keep up on the news, and I post some of this stuff on my Facebook, what have those guys done to hedge against losing profits in Bitcoin? Anybody know? What's kind of become popular is people mine altcoins. So what you do is you mine a different coin other than Bitcoin, which has a lot less competition. Your computing power has a lot bigger impact, so you maybe get a larger reward. Then you sell those altcoins for Bitcoins, hopefully getting more Bitcoins for that sale, for that transaction, than you would have been able to mine Bitcoins directly. And what we've even seen, and we looked at this, I think, on CEX when we were talking about CEX, lots of mining pools now have something called a multi-pool. And a multi-pool rarely mines Bitcoin. Multi-pool has a list of altcoins that it mines, and at any point in time, it's mining the most valuable of those altcoins. That is the most valuable one relative to Bitcoin. And then a lot of those multi-pools will instantaneously turn your altcoins into Bitcoin. Now, we're not talking like the difference between, oh, I'm making 5 cents a day to now I'm making $50 a day. We're talking maybe instead of 5 cents a day, I'm making 9 cents a day. But that's almost 100% better return. I mean, it's pretty substantial. So it becomes kind of an interesting thing. You know, I have a buddy of mine who lives in Chicago who's big into mining stuff, and something that he did, there was a coin called Max Coin, and when it first came out, it was kind of popular. It was a big, you know, all these security things that people thought were cool. So he took all of his Bitcoin mining equipment, and he decided he's going to solo mine Max Coins. And initially, Max Coins, you know, everybody was just trying to get Max Coins. No good reason, but so it had a high value relative to Bitcoin. You know, so maybe if you had 100,000 Max Coins, that would be equal to 1 Bitcoin. Well, different coins have different rewards. Bitcoin, every 10 minutes, 25 new Bitcoins are born. Some of these coins, every 10 minutes, maybe 1 million coins are born. That's not unlikely for some of these coins. So they make up for it in bulk. Well, he decided to mine it solo, not as part of a pool. And because it was so new, he ended up winning. So he won an entire block himself and had something like 1 million coin payout, which he converted into 5 Bitcoin. And that was when Bitcoins were worth about $700 a piece. So he took the equivalent of a piece of mining hardware that, I think he might have done this with a video card, actually. I mean, this was like not good mining. So just kind of giving you an idea, you can play the lottery with Bitcoin if you want. Say, I'm going to go out on my own. I wouldn't do that with Bitcoin. But with altcoins, you know, pick a fun one that you don't think a lot of people are on. Just see if you win. So what he did is he mined for like 4 or 5 hours, won a block, immediately turned it into Bitcoin, immediately sold those Bitcoins, made something like $3,500 with a graphics card. And this was like, I don't know, two or 3 months ago, something like that. Not that long ago. You know, well after it was already out of control with these ASICs. So kind of an interesting thing. But he could have also had his graphics card going for 6 years and never won a block and just be paying that power bill. So it really is like buying a lottery ticket. But it is kind of an interesting thing because Bitcoins really have become somewhat unattainable at the beginner level or even at the hobbyist, you know, the medium hobbyist level if you're going to directly mine Bitcoin, unless you're in it for the long haul. Because one thing you could take advantage of is if the big banks start stepping in and they start running the Bitcoin mining operations, what you might have is they might get into a conglomeration where they drive the difficulty back down, which makes your old equipment potentially more relevant. That make sense? This is all speculation, right? But so in any case, on number 10, you can answer that several different ways. You can say it's been positive. You can say it's been negative. It probably depends on who you are and where your current, you know, whether you're an interested party on the outside or you're actually somebody who's currently mining stuff. I know that my personal Bitcoin mining equipment is worth far less now than when I first bought it. Now, having said that, I also think that Bitcoin mining is becoming less popular. So because it's becoming less popular amongst the masses, I think that over time, my equipment will actually appreciate in value, hopefully back to about where it was when I got it. But you got to sit there and wait. Well, that's okay. You know, maybe one time, at some point, I'll be sitting on 1 million Bitcoins worth, you know, 0.000001 cents a piece. So I can go to McDonald's, but I'll have to convert to Apple Pay. All right, questions about that? All right, any general questions about the exam? Okay, so what I want to do now, and you can come up after class if you have want me to tell you why I took points off or something. Because we only have a few minutes left, I actually want to jump into our slide set, and I want to talk a little bit about what we're going to be doing right after fall break. We are going to come back next class and try to finish up our parser in preparation for what we'll be doing after fall break. But we do have a few minutes, so let's... Whoa. 10, 16, pick the most recent. Got it. Okay. So I'm going to come down here. All right. So we are going to look after fall break at utilizing the blockchain, utilizing blockchain technology for a non-cryptocurrency problem. So this really might be the future of our cryptocurrencies. We can say all we want, whether or not Bitcoin takes over or US dollar fails or all this other crap. All that's speculation and highly, highly, highly speculative. But at the very least, from a security perspective, there are plenty of things that the blockchain and its surrounding technologies have to offer us, right? It's far easier to counterfeit US dollars than it is to counterfeit Bitcoin. And that's because of how the blockchain works. That make sense? So, you know, nobody's going to argue against that. The question is whether or not that's worth it. But now, a problem that would be interesting for us to look at is the idea of voting. So if you go and you cast in your ballots, like what is it? Is it a couple of days here until the governor race for Wisconsin? Isn't it like I think it's like soon, isn't it?
Somewhat soon.
They seem to be screaming a lot on TV. I hear it. So I think it's pretty soon. But one of the problems with voting that we've dealt with over the years is A, we don't know whether votes have become corrupted, right? Whether they were corrupted or not, we aren't necessarily confident that we know how to count them. What year was it? I mean, some of you might have been pretty young. Do you remember with the Al Gore, George W. Bush? Huh?
Florida was like a big.
Oh yeah, yeah. How old were you then?
I was like, maybe 6.
Okay, yeah, see, it doesn't seem that long ago to me, but I mean, I'm old. So that was great television. For about 3 weeks or something like that, we're talking about hanging chads and all this stuff. Yeah, these seniors in Florida, they don't know how to vote, right? Well, I can vouch for that. I have grandparents that live down there.
Actually, that's probably around 12. Because that was like 2 terms. No, 3 terms ago.
My grandparents are hilarious. My grandpa is got all sorts of breathing problems and stuff, and they were at some dinner or something the other night, and he started having a problem. So he made them call 911. They came and picked him up in the ambulance, took him to the emergency room, and then he's got all these mood pills because he's got some issues. Got to the emergency room and refused treatment. Decided somewhere on the way he was done. That's our tax dollars. That's Medicaid paid for that trip. Okay, so in any case, we want to look at how we can take the blockchain technology and apply it to a problem like voting. So in the simplest step, let's just assume we have 2 people going against each other. Okay, so we have Amish versus State Farm. Okay, they're running for class president. Highly. Why don't we have class presidents?
No one cares.
Yeah. Well, why do we have homecoming courts? Like I saw the voting thing for homecoming king and I thought that's a high school thing.
Some people don't want to let go of high school.
Seriously. Okay, so we have 2 people running for office. At the high level, how can we use the blockchain to allow us to vote for one of those 2 people? Go ahead.
Set up the 2 people with accounts.
Okay.
And only allow them to receive these coins or whatever they are to be sent from everybody else. So we all have accounts, but they have the only accounts that can receive the coin.
Okay.
And you just send 1 coin per vote.
Okay. So at the simple level, we're actually going to utilize the currency. So we'll say 1 Bitcoin. Kind of gets expensive, but for the simple purpose, we're going to say 1 Bitcoin. We're going to have each of them set themselves up with a wallet, probably the government entity that's managing the actual vote. They'll set up the 2 wallets, right? 1 wallet, all votes should go to for Amish. Another wallet, all votes should go to for State Farm. All right? And then as people come in and vote, those people will cast their vote by sending a coin to the appropriate wallet. Right? And we know those votes will only get counted once because those transactions cannot be duplicated. We can go back and double, triple, quadruple, quintuple check the vote because we can look at the blockchain and see how many transactions went to each of those wallets. So we can have 3rd and 4th and 5th party places come in and validate the vote. In fact, any citizen could go out and validate the vote on their own. So it would be very, very difficult for votes to become corrupt. Does that make sense? Okay. That seems good, right? What's the downside?
People do more than 1 transaction.
Say this again?
People do more than 1 transaction.
Okay. So how are we going to protect people doing more than 1 transaction? How do we look at a unique transaction? Assuming we're doing 1 Bitcoin. A unique transaction would be from 1 Bitcoin address to another Bitcoin address. Correct? How do we keep people from doing... What if I have 5 wallets? I have 5 different Bitcoin wallets. Can't I go and...
They create a new currency, I guess. But
Unless the government is regulating you have to use a special wallet. And the government
Okay, so maybe the
regulates
government
that.
has a wallet,
Yeah.
right? So how does the person uniquely identify themselves on there?
Social security number.
Could be social security number. Okay, so we're going to be looking at blockchain to deal with two separate things. One side of it is to limit the number of votes that any individual makes to one. The other thing is to make it so that we have a public record of all vote counting. That we don't just rely on some third-party place to say, oh, so-and-so won with 62% of the vote, where they're actually, calling it before the polls have even closed? Doesn't that seem stupid? All right, so on Wednesday, we'll come back, we'll try to finish our parser. So we're ready to go. Then we are on fall break Thursday and Friday. And then on next week, we're back on Monday, and we'll hopefully pick up on our voting stuff. If you have any questions on your exam, feel free to come up. I'll try to explain why I did what I did. And I'll see you all Wednesday.